hello and welcome to All I Want for AWS is Allow Star. My name is Chris Elgee. I work for Counter-Hack Challenges. We have the great privilege of bringing you the SANS Holiday Hack Challenge every year. I'm so glad that Santa invited us all back to the North Pole. I am a challenge developer and also a penetration tester at Counter-Hack. I also have the great honor of being a SANS instructor for both enterprise and cloud pen testing. Let's get on with the talk. So we're going to talk about control plane versus data plane, what they are, why they're important, and we'll spend most of our day really working in the control plane. We'll talk some about identity, and you can decide whether or not it is the new perimeter. We'll look at different ways to get to AWS, the web console, the CLI, and some others. We'll go through the interesting set of rules that govern how the AWS permissions model works, and we'll spend some time in the AWS CLI. And hopefully that will help you get a little farther along in Alabaster's terminal. Okay, so first, control plane versus data plane. We have assets. They are rocket ships and I guess maybe a Viewmaster wheel and the Pixar ball. We have things that we want to get to, and we're normally used to interacting with these things over the data plane. We use TCP/IP and UDP and ping and traceroute. We use all these types of connective tissues, right, to go from where we are via a web browser or maybe curl or nmap to connect to these resources. And that depends on DNS name resolution and internet gateways and routes and firewall rules, right? So that we can go from where we are across the internet to those resources to hit that open port and interact in a specific way. Enter the control plane. This is the other way to get to things in AWS, the way to get to these assets. And the easiest way is the web console. This is where we log into a web browser and we navigate to our account and we can view our EC2 instances or Lambda functions or S3 buckets and deal with them there. Now, you might say, well, Chris, you said the web browser is part of the data plane down bottom, and well, yes, but not in this case here. We're using the web console to reach in through the top and interact with these resources, whether they have IP addresses or not. You can think of this kind of like when you spin up a VM in VirtualBox or VMware, and you can interact with it right through its desktop, regardless of whether or not that VM even has a network interface. You're more or less going through the control plane in that instance. So we can use the web console, the CLI, and some other things here to connect to AWS via the control plane. And we'll look at a few of those. So identity is what gets us access to our assets. We get them there in the upper right. And now I am a dog. No. I am a curly-haired person. No, I have to keep my hair short for drill. I'm also not a cat. I'm not a long-haired person. That might be Lynn, actually. She has all the magic that runs the Counter-Hack offices. Anyway, I'm actually the guy with the nice haircut, thanks for noticing, and the polo shirt, and I need to access some of these assets. But to do that, I need to have some kind of policy document allowing me to do so. So we have all these documents that might be attached to users or identities or groups. And they might say that I'm allowed to access the rocket ship or S3 buckets, or maybe only in certain circumstances may I access the CloudWatch resources. On the other side of this, we can also have policy documents attached to the resources themselves. So maybe there's a policy document attached to that bouncy ball that says if you are a member of this project or if you are coming from this specific resource, you may access the bouncy ball. So policy documents can be attached to identities or to resources. Net effect is they say, yes, you can access this resource. And where does this actually happen? Is this over the data plane? No, this is over the control plane through AWS magic. Doesn't matter where in the world I am, what my IP address is. It matters what my identity is and whether or not I'm explicitly allowed to access that object. So with the right document on the internet, AWS will know that I'm a dog. So here's the list of 316 services across the AWS CLI that we might interact with. feels like a lot. Don't worry, there are usually only a few that you actually need to interact with, and we'll explore some of those here. And we can do that through the AWS Web Console. Here it is. I'm logged in. I'm looking at my console home. I can go to EC2 and maybe spin up some virtual private servers. I can go into IAM, that's Identity and Access Management, and create users or manage keys. Here I am listing my instances, my EC2 instances. I have none. That's sad. Maybe I can create a bucket in S3. Or here I am playing with users and seeing what I have for existing keys and what's out there. Maybe I should delete those test keys. Those look old and unused. So this is the web console. There are also programmatic ways to interact with AWS. I like using Python for a lot of things, and there's a library, the Boto3 library, that lets you interact with AWS using your permissions, whatever you have via the CLI typically. You can use Python to do all the same things: create buckets, copy files, create users, create VPCs. You can do all of that with Boto3. There's a separate platform called Terraform that can do all the things, not just in AWS, but also in Azure and Google Cloud. And it can create and interact with resources at any scale, really. If you take Sec588, the Cloud Pentesting class, the script that Moses Frost wrote to create the range for that class is, I think, 170,000 lines long. It's all Terraform, and it creates a very large environment. So Boto3, Terraform, these are some programmatic ways that we could interact with AWS over the control plane. The focus today is the AWS CLI. Here is a shot from Alabaster's terminal. He needs help. Please hop over there. And the first one isn't too bad. It's largely just getting started, running the help function. He needs a little help getting his IAM credentials entered in, and then just a couple of quick commands, and you should be all set there. The second terminal is going to get a lot more complicated. We're going to be looking at policy documents and how those allow us to get to certain resources that maybe we shouldn't be able to. It's kind of an audit / privilege escalation situation there. And this can all happen by the CLI. So here's this, in this second instance here, a much more complex command beginning with AWS, and then which service? IAM. And then which sub-function of IAM? Well, I want to get a policy, a specific version of it. Well, which policy is it? Well, let's set an argument here, the policy ARN. ARNs are Amazon Resource Notation. They're these long strings of things. These are the reason why copy and paste are so popular with the AWS CLI. There's just a lot going on. But this command is asking for version 1 of this particular policy, and it gets dumped out in JSON format. You know it's JSON because it's curly braces and colons all the way down. All right, so that is a look at the CLI. Before we start playing with it a bit ourselves, let's talk about how those permissions work, because this is really key to security in AWS. So first things first, there's the root account. When you create a new organization in AWS, there will be one root account, and the root account can do everything. So from here on, we're going to be talking about different policy documents that allow certain things, that disallow certain things. None of that applies to root. Root can do all the things. So do not get root wet, do not feed it after midnight, and do not generate access keys. And we'll see access keys here in a minute. We instead want to create other users, and they can have password access, right? Because winter 2022 ! Is going to keep everything safe. Just kidding. You can also federate it. If you have maybe Azure AD or Ping or Okta, you can federate your organization's identities to AWS so that they can log in with the credentials they already have. Or we can use key-based access, and this is wonderful for the CLI. And here's what that might look like. So maybe I'm going to create a new user here, someone named Shell, and I'm going to create it with an access key. So I go through the web console here, create the user, and then it gives me this access key ID, which is more or less kind of it's not a username, but it's a similar concept, and a secret access key, which is more or less a password. It's long, so I guess we don't call it a password, we call it a key. But anyway, that's all you need to access AWS as this user shell. Now, imagine if you had done this with a root account and then shared it in a presentation at KringleCon. people across the internet could do whatever they want with your root credentials. So we don't want to create keys for the root account, but for lower privileged accounts, it's generally okay. So what can my shell user do? Well, it depends on what those policy documents say. And there are different flavors of policy document. The first kind is AWS managed. This is where AWS has created some example policies for maybe a log user or a backup operator or a certain developers. And these are policy documents, managed policy documents that we can assign to specific users, or maybe it makes sense to assign them to a resource. If we create our own managed policies like this, these are customer managed policies, and we can make our own backup operator policy and apply it to whoever needs that. The third type is an inline policy. An inline policy is one that a user creates, an organization creates, and then applies to one specific identity or resource. So it's like a customer managed policy, except it only lives in this one place and can't be applied to other entities. Now, what makes up a statement? What makes up a policy document? Well, it's going to look something like this. Again, we're in JSON land, right? Curly braces, square brackets, quotes, and they always begin with this version up at the top there, and then one or more statements. Here we have one statement. The statement says, I want to allow. The effect of this statement is I want to allow whoever has this policy to do some things. Who is doing this? Who is the subject of this policy? It depends where it's attached. Now, the object of the policy, who is this acting on? In this case, it's star, everything. So this is, I'm going to allow someone to interact with everything with a certain condition. The condition here is only between December 1st, 2022 and January 10th, 2023. So this policy only will do anything, is only useful in that roughly 41-day time period. Now, what can someone do with this policy? Well, they can list all my buckets. So they can get a listing of the S3 buckets that they have access to, right? So that is an example permissions document. Let's look at another. This one gets a bit more complex. Here we again have an allow, and it's going to let us describe star. So describe instances, describe internet gateways, whatever. Also get console star. So get console output, get console screenshots, and in resource star. So if you have this, you're going to be able to do those functions, those EC2 functions. These are EC2 services with anything. Additionally, we're going to allow you to run instances in EC2 for these types of resources. So another allow type policy. What if we do something else instead? What if rather than just explicitly saying this person, this identity can do this thing with this resource, what if we say you are allowed to assume certain roles? So you are maybe a new employee here at the North Pole, and you need to be able to help with KringleCon 5. You're here at Holiday Hack 2022. We're going to allow you to assume the role of any resource that is tagged with Project HHC 2022. So we're going to allow you to assume role for any resource as long as it is tagged HHC 2022. So maybe we have a terminal or some crazy elevator that we need you to impersonate to do some testing. This, when attached to your identity, will allow you to assume the roles of those resources and then see, how they work. On the other side of that is the pass role. Let's say you have certain abilities. You can read S3 buckets or different types of logs. We want you to be able to pass that role in, for whatever resource, specifically to CloudWatch. So you want to maybe this is to enable some security function, right? You want to be able to track different things going on via CloudWatch. So you are allowing users, you're allowing identities to pass role, to pass their privileges on to the CloudWatch service so it can keep an eye on the things that they have access to. So assume role is when you pull in access to some other resource, and a pass role is when you give that access to another resource. All right, let's get a little weirder. So first, what if there's an allow and a deny? Here's an allow, It is for getting S3 objects anywhere. So I can download all the things out of the buckets. That's great. Maybe I can't list them, but if I know what they are, I can get them. At the same time, though, I have a deny for S3 buckets when the project is marked Santa's tool. So with this policy here, with these two statements, I can get anything except things tagged as Santa's tools. So far, we've had actions. This is our first not action. It looks strange. It is strange. What this is saying is not that we're denying S3 access. It's that we are allowing everything but S3 access. So with this policy attached to a user, they could now perform all IAM functions, all Lambda functions, all whatever, but they just can't do S3 functions. This is a really weird and dangerous concept that not only does AWS not recommend, but also hacking tools. Here's PackU, some of the help text in PackU saying, yeah, not actions are really strange. If we see any of these, we're just going to flag them for you, and you can kind of poke them. Another tool, a security auditing tool, Scout Suite, when it sees not actions with allow, it says, yeah, there's a not action with allow. This is probably bad. Go ahead and take a look and let the individual know. So not actions, really weird, really strange. All right, so let's go to the CLI here for a minute and play around a little bit with how that goes. So let's start by doing something like AWS configure. Now, this is what we do to initially set up our CLI so it knows who we are. So we've gone in, we've created keys for that username shell, and then we can just copy and paste them in here. And then I can set configuration things like, all right, I want to use US East 1 because that's kind of close to where I'm at. And then, all right, I should be all set. Now here in my .aws directory, I see, all right, config and credentials. I can cat config, and this is all right, US East 1. So by default for region, because resources all live in different regions, it's going to default to US East 1. And if I cat credentials, I can see the stuff that I just put in there. So the access key ID and the AWS secret access key. So cool. Now the who am I in Windows and in Bash is who am I, and it tells you, oh hey, you're Chris. In AWS, it is AWS STS get caller identity. Now I'm going to run this through a little function here to obfuscate what comes out of it. But you can see here I am this user ID. That's interesting. I'm this username, so I am that shell user. My little obfuscation function changed my account number to this. Those aren't exactly like a password, but it's still not supposed to be public information. So as we go through this, forgive my security guy skepticism of the internet, but I'm gonna obfuscate my account ID as we go through. All right, so we can also, now that we know we're shell, we can say, all right, what access do I have? So I want to use the IAM service, AWS IAM. If I want, I can help, and I can see all the different commands available under the IAM service. That's cool. But in this case, I know I want to do list attached user policies. And this is asking, hey, for all the managed policies available, which ones are attached to this user? And it'll search through and say, oh, actually some great ones. You can do all kinds of crazy cool things. That's neat. Awesome. We can also do a slightly different command, list user policies. This looks for inline policies. And in this case, we don't have any inline policies that apply directly here to shell. So, all right, how about AWS EC2 describe? It's always harder to type when people are watching. And I'm going to run this through obfuscate as well. And bang, I got a huge blob of JSON back telling me all about my instances. Now in this case, I'm just really interested in, let's say, the public IPs. And here we see I have a public IP address. So if I want, I could SSH EC2 user at that IP address with this certain key that I generated in the web console, and then I can connect up to that instance. Great. Over the data plane. All right. How about S3 buckets? Well, I can AWS S3 API and list buckets. So I don't know what buckets I have. I just want to see what's out there. And it says, oh, you have this one called Holiday Hack Bucket 2022. Interesting thing, by the way, those names have to be globally unique. So I tried to create a bucket called Holiday Bucket, and AWS said, sorry, you can't do that. There already is one. So this is part of the reason why exposed buckets are such an issue. If you can guess a name of a bucket and it's open, then you're going to be able to access the things in there. All right, so AWS S3 LS. So I'm sorry, listing buckets is an S3 API service function. The rest that we're going to use are S3 service functions. That's just kind of how it goes. So I want to list what files are in that bucket. I get nothing back. There are no files in that bucket. I can just copy things to that since I have S3 star permissions. So I'm going to S3 copy this file I have here, regions.txt, up into S3, that name, and then bang, it uploaded the file. So I can go back to my list function or my list command, and I see, all right, my 203 byte regions.txt went from my local system up into the cloud. So if I accidentally delete my regions file, then I could AWS S3 copy from the cloud down to localhost, and then I can cat my regions file. Oops, not that one. Oh, you know what? I didn't grab the file name. How about that? Regions.txt. Copy that locally. There we go. Now I can cat regions and pipe it through lolcat to make it beautiful. And there we go. All right, so getting back, we're out of time, but if you'd like to learn more about the AWS CLI, I recommend first helping Alabaster. He could really use your help with those terminals. So please give Alabaster a hand. Next, I would recommend just building something. Play around. Open the web console, create some instances, create some policies, some users, and just see what you can make. Once you've made something, try PackU or Scout Suite. Run those tools against your infrastructure, your IaaS candy up there, and see what comes out of it. See what mistakes maybe you made or things you could do differently. Lastly, you could take a class, right? AWS has lots of classes and certifications, and so does SANS. I would love to have you in the classroom sometime. So check them out and see what fits your needs and where you're trying to go. With that, thank you very much for coming up to the North Pole. Thanks for listening to All I Want for AWS is Allow Star. Have a great con.